All right, welcome back. It's a little bit quieter. Wind picked up, but the cat is napping, and the guys outside are taking a little bit of a break. So we're going to work on number 12 here. Okay, we're going to come back to the other ones, but we will do this. It says determine whether or not the series converge or diverge. You do not have to compute the sum. Okay, so fantastic. This will be the same kind of a problem. Use comparison or limit comparison tests. Okay, because sometimes, and I get it, without a lot of practice, which we haven't had, and I'm sorry about that, without a lot of practice, it's hard to know exactly when I should be using these. So even in the last class, this was taken from the class we had face to face. We had a lot of time for limits then, and they're like, could you give us a prompt? I said, yes, I'll give you a prompt. Which one are you supposed to do? Okay. So, all right. So here we go. Let's figure out what we're doing here. So here's the first one. Spoke too soon. All right, so we have limit n is equal to 0 to infinity, and we want 1 over 3 to the k plus k. So actually, let's change these so they're consistent and make this n or make that a k. All right, I'm sorry about that, but there we go. Okay, so we want to compare to sum over 1 over 3k, I think, right? We have to test a couple of things, right? So the idea is, we'll call this b of n, we'll call this a of n. If b of n converges, right? So we'll say this, if b of n is always greater than a of n, all the terms here are bigger than the terms here. Okay, we'll do that. And b of n converges, then a of n will converge. Okay. If b of n diverges, I can't say anything about this. I'm like, well, it's too big. I'm like, it's smaller, but I mean, is it smaller enough? I have no idea. So if this one converges, it kind of squeezes this down into convergence. Okay. And for this one, we're going to have something like that. And then this one is going to be something like that. This one's going to converge. We're going to be able to sum this one up. The a of n here is also going to converge because it's always, well, not always, but I think except for one term, it's smaller. Okay, so let's go test that. Okay, so let's take a look at, we'll set n is equal to 0. Let me pause and see if I can close the door here. All right, that might help a little bit. Okay, so when n is 0, let's just go ahead and take a look at what an is, right? That's going to be 1 over 3 to the 0 plus 0, that's 1. What's b to the n? Or when n equals 0, that's 1 over 3 to the 0, that's 1. Okay. What about the next one? How about when n equals 1? Right, we got 1 over 3 to the 1 plus 1 versus 1 over 3. This is 1 over 4, 1 over 3. 1/3 is bigger than a fourth, right? I'd rather have 1/3 of $1.33 than 1/4 of $1.25. Okay, how about n equals 2? Right. So here we're going to have 1 over 3 squared is 1, or 3 squared is 9 rather, plus 1 is 1/10, oops, plus 2, 11. And then this is going to be 1/9, right? 1 over 3 squared. A 9th is bigger than 11th, right? And that's the way it's going to go for the rest of time. Okay, so except for this first term, b of n is always bigger than a of n. Okay, so let's look at the behavior of b of n. Well, we could look at this. We could say, I could have swore I'd seen something like this before, right? That's a geometric series. Not only is it a geometric series, it's a geometric series with r is less than 1. This converges, right? This is a over 1 minus r, isn't it? This converges. So, excellent. So since the bigger function converged, the smaller function will converge. So since over 3k converges, 1 over 3 to the k plus k converges by comparison. You get in the habit of writing by the test that you used so that if somebody else wants to know, like, oh, how did you show that that was going to converge? Like, it came to me in a dream. No, don't write that. Okay, by comparison. All right. Or by ratio, or by whatever you use. Okay, in this case, by comparison. All right, next one. So this one, I'm going to have to find a slightly easier problem, because last year when I gave this one, maybe 2 years ago, when I gave this was probably the hardest problem that was on this exam. And it's not my intention to torture you this way. I was honestly surprised, but yeah, that's the way that works. So this is sum k goes to, okay, good, I was consistent with my k. So let's go ahead and write this down. Okay. I taught everybody, when they were working on it, I'm like, oh, I can't see it. I'm like, when you see it, you're going to kick yourself. All right. But I will find something a little bit better for us. That's a mess. I mean, who wants to look at that, right? And there's nothing we can do about it. You're just stuck with that. But why don't we make this a little bit cleaner, and we're going to compare to, oh, there's a +1 here, isn't there? We're going to compare to k to the 2/3 over k cubed. Okay. So we're going to compare to k to the 1/3, or 2/3 rather, over k to the cubed. Okay, so this is k 2 over 3 over k cubed, which is really k to the 2. I'm going to keep this, okay, because we're going to need it a little bit later. But this is like to the 9/3. And this is k 1 over k. And we have a fraction with the same base. We get to subtract the exponents. So we're going to have 1 over k raised to the 7/3. Okay. I want you to be thinking p-test about now, right? P is bigger than 1, what happens here? And if p is bigger than 1, then we converge. If p is less than 1, like 1 over square root of x or something, then it's going to diverge. Okay, so there we go. I don't want to just compare it, because this, I don't know if I can prove that this is always strictly smaller than that one. I mean, we could probably do a couple of things here. It is always positive though, right? This is always positive. So this, all the pieces here are always, especially since k is equal to 1, right? Always positive. I mean, cube thing could be negative, but not if the inputs are positive. So this is always positive. So what I want to do here is I want to use the limit comparison test, and I want to compare it to this one. Since I know what happens to this function, right? It converges with a p-test. So the things you have to check for limit comparison is, well, are they both positive? Yeah, they're both positive. All right. Now the result is, like, we'll get some kind of a thing here. We're going to get limit as k goes to infinity, right? Of, again, we'll call this my a of n, and this will be my b of n, of a n b. Oh, we'll say k. Sorry, we'll use k's. And if this is equal to a positive finite number, right? If c is a positive value, right? Not infinity, a value. Then it doesn't mean they converge. Okay, it means their fates are linked. Okay, so I think of a movie or a story where they did this. I'm sure that some of you guys are better movie watchers than I am, but there's got to be some kind of poetic thing, like their fates are intertwined, so goes one, goes the other, kind of a thing. So that's how I think about it. So if this is going to be a value, since I know this one converges, the other one will too. Okay, so let's go ahead and work that out. So what we're going to do is we're going to write down, this is the limit, right, of the cube root of k squared plus 1 over k cubed plus 1, and this is divided by, and then we're just going to have, like I said, I'm going to write it this way, even though I evaluated it to do this, because I want to be able to cancel some stuff. So that's going to be the cube root of k squared over k cubed, right? So that's what we have here, right? This is the cube root of k squared. So what we're going to do now is we are going to employ our powers of fractions, right? K cubed over cube root of k squared, right? So let's put this together in things that are going to make sense. So let's just group these together. Okay, so this is going to be k cubed over k cubed plus 1. And in this, since they're both cube roots, we're going to be able to say the cube root of k squared plus 1 over k squared. Okay, does that make sense how I can match these two up and then match these two up? And since this is a cube root and that's a cube root, they can all go under the same cube root. Okay. So we have to look at the limit and the limit, right? Because that was a property of limits you learned way back in Calc 1. If you have the limit of a times b, that is equal to the limit of a times the limit of b. Right? Limits are very forgiving with distributing over stuff or putting them where you need to. So, we're going to abuse that right now. So if I look at the limit as k goes to infinity, right, of k cubed over k cubed plus 1, what we're going to do is we're just, don't use L'Hopital's. K cubed 1 over k cubed, okay? So we're just going to do that. So this is going to be 1 over k cubed times k cubed, or k cubed over k cubed is going to be 1, plus 1 over k cubed. We know what this limit is. This limit is 0. So we have 1 over 1 plus 0, which is 1. Okay, beautiful. What about the other part? Right. So this is going to be the cube root of k squared plus 1 over k squared. And again, I'm going to multiply by 1 over k squared, 1 over k squared. Okay, so we're going to end up with the cube root of 1 plus 1 over k squared all over 1. Okay, we know what happens to this limit, right? That's one of the things you learn in Calc 1, that's 0. So we end up with the cube root of 1, which is 1. 1 times 1 is 1. Hey, what do you know? C is a positive finite number. So I know that whatever happens to one of these, it has to happen to the other, okay? Like I said, their fates are linked. So since k to the 2/3 over k cubed converges by p-test, cube root of k squared plus 1 over k cubed plus 1 converges by limit comparison. That's it. Like I said, this really threw my last class for a loop. And I mean, it's not like I didn't have really capable students. I looked at it, I was like, how are you not seeing this? But I didn't say that to them. That's not fair. Okay. And the people that were stuck in the final, it's the end of the final. It's the last one you're doing. I get it. So I will rework something like this. It'll still be like, it'll be a comparison test or a limit comparison test. Okay. I'm not going to deviate from that, but definitely take a look at those. And again, I'm not trying to pick the hardest one you've ever seen before. Okay. But that's the kind of thinking you need. Actually, I know that's exactly why they had a hard time with it, because this is weird thinking for the math that you've seen up till now. But I'll try to find a more tame limit comparison test for you to do to deal with that. All right. So there we go. And of course, I may swap. Right. I don't want to give it away too much, so I'll try to swap which one goes where. All right. So very good. That's the last one. Well, it isn't, but I'll be going over some of these other ones as well to fill this out, and I'll put them up. So thank you, and good luck with that. Hopefully you can get a really good start on your final exam prep at this point. All right, so let's go ahead and be done.